Today, we'll discuss how you can scale your codebase with evolutionary architecture. So, what is evolutionary architecture? Well, it refers to a software design approach that embraces change as a fundamental aspect of system development. Instead of aiming to create a fixed and perfect architecture up front, it allows the system to evolve in response to new requirements, technologies, insights, etc. And evolutionary insight is a critical tool for reducing technical debt. So let's talk about terminology. Evolutionary design or incremental design is another term for this approach. Generally, evolutionary design refers to changes on a smaller scale, such as refactoring code or new features, while evolutionary architecture refers to changes on a larger scale, such as reorganizing the code base or splitting a monolithic application into microservices. That said, there's no strict boundary between the two terms, and we will use the term evolutionary architecture in this video. So we will provide an example of scaling your code base to accommodate a growing number of features and developers. So let's start with the current architecture in this example. So this example is based on a theoretical company, a theoretical code base, but I do use some real-world experiences to inspire this example. And of course, the problem and solutions that we discuss are kind of common in software development, especially for startups and smaller companies. Let's jump into the initial state of our example code base. So we have a web application developed in a monorepository. The application was built from ground up with the simple architecture. And of course, early on, the architecture was focused on adding new features and finding product market fit. So here we have a few large modules. And I use the term module loosely to refer to basically a logical grouping of code in the same files and directories. So, when things were small, things were pretty straightforward. You knew where the code was kind of. And, since the database was small, developers were familiar with the whole thing and things went smoothly. But then the application has grown significantly in terms of features, complexity, and team size. Now the organization has 3 product teams working on different functional areas of the application, and no one has updated this initial architecture, which is insufficient to support the growing codebase and development team. So let's imagine that we have this architecture, we have a good-sized team. What are the problems that this company is going to see? Well, first, and probably the most critical problem is an increase in bugs, longer time to fix bugs, and just a general decrease in quality, right? One of the causes is that you would have different features that are spread out through this code base, right? Let me switch colors. And then in order to fix a bug or figure out what a bug does, and a developer has to go and understand and link in their mind all these different parts of a feature. Meanwhile, there's like other code spread around that is muddling the situation. And this other code, can be unclear, right? You don't want to change something in your feature and then have the other code break. So it's basically this complexity, right? This increase in complexity has making, creating more bugs, making them longer to fix, as well as, breaking existing features. So speaking of new features, obviously the same issue applies. It is harder to add new features when you've got, when you have to add a feature and put the code sprinkled throughout other features. And basically, the code base has become a tangled web of dependencies, and any change in one part of the code base can have unintended consequences in other parts. This means to actually be productive in this code base, an engineer has to understand the whole thing, right? And that is pretty unlikely for a large and growing team and code base. So the result is adding new features is taking significantly longer to implement than initially estimated. And oftentimes engineers would estimate a feature based on their experience from a year or two back when the code base was much smaller. But now things are taking longer because there's more interaction, more complexity. Another thing to mention is feature branches, right? We've got the trunk development, and then maybe we want to have a feature branch where we code up our feature. Well, the merges both this way and back to main have become difficult, right? Because there's more merge conflicts. And the fact that the code is sprinkled throughout increases the chance of a merge conflict. What this means, if there's an increased chance of a merge conflict, developers are going to become conservative, and they're gonna, they're gonna reduce the amount of refactoring and cleaning up of the code base. And it's almost like a perpetual cycle. The less you clean up, the worse the code base and the code quality gets. Now let's talk about tests. We have 3 teams. Team 1, and they're all their code is intermingled with each other. So they're often breaking each other's tests. So the test suite is frequently broken. There's also no clear ownership of the tests. So engineers have been reluctant to fix them. In some extreme cases, some engineers have even stopped paying attention to the alerts from your continuous integration system, figuring most of the time the problem's caused by another team, and we'll give them a chance to figure it out. And if tests are still failing in a few days, maybe I'll take a look to see if it's my problem. All right, let's see. And of course, the tests have also become slower. One extreme example is some integration tests. So you would have an integration test that tests the API. That would include the service layer, the data store layer, and would actually run on a real database. And in order to compile this test, you basically pretty much have to compile the entire code base. And then these tests, by their nature, they're hard to parallelize. They're hard to parallelize. And another thought I had, and then when new features are added, that simply just extends test time, right? Because it extends compile time, and because they're generally not parallel, it'll just extend your test time. And finally, onboarding time for new developers has increased for obvious reasons. All right, now that we've covered some bad stuff, let's look at some alternatives, all right? Where could have this company been at this point in their company life? So we'll take an example of maybe what a good architecture could have been for this company that wouldn't have as many of these issues. All right, let's switch. All right, so we have 3 product teams, and ideally we would have had the code base split kind of like this. All right, by feature 1, I basically mean the product team, which could have 1 or more features. So each product team would have their own list of their own code modules, and a logical separation, a logical or even a physical separation in their database, right? So each group would have a slice of the product that they would own. Now, inevitably that there would be some shared code, Perhaps the shared code would be owned by the more senior members of the team, and they would be explicitly, be responsible for it. So the immediate benefit here is that the amount of code each team member on this team has to understand is significantly less. And then the problems, let's go through the problems that we mentioned before and see how this good architecture solves them. All right, so let's see. Obviously, like I just mentioned, the complexity is less. If the complexity is less and it's easier to understand the code base, naturally it would lead to fewer bugs and faster to fix bugs. Also, feature development would be sped up, right? Because in general you have clear code and fewer dependencies. And as you know, these things kind of feed on each other. As you start improving one thing, other things improve as well. Merge conflicts for feature branches and just PRs in general would be considerably less, because you largely only have to worry about your team's code merging in, and you don't have to worry as much about the other team's merging code, right? So there'd be less of this, oh man, there's a merge conflict, I need to get another PR. There would be less this frustrating overhead that developers don't like to deal with. Also, the test suites would naturally be cleaner in terms of fewer failures, because there would be a clear responsibility on the tests. The tests themselves would be narrow, right? For example, the API tests could just involve this part of the code. And the alerts for those failing tests would just go specifically to this product team, right? So there would be less alert fatigue for the entire team in general, because alerts would be targeted at specific teams. And of course, the tests themselves would be faster, because they would be 1/3 as big, effectively. And because of this, understanding, etc., onboarding time for new developers would be faster. But in the real world, right, this company does not have this architecture. And I would argue that building this architecture up front would have been foolish, since it would have consumed critical engineering time for at that point, a much smaller code base that would have been just easily understood by engineers at that point in time. Yes, there would have been value thinking ahead and creating this architecture, right? And this value would have saved time in the long run. But for a young company that's trying to find its market fit, thinking ahead and planning several, 3 years ahead would have been, a little. The value would have been insufficient, because the company itself may not be around in a few months. All right, we went over the current architecture of this company, the good architecture that it could have had, and let's go to the next part, evolutionary architecture, right? What can the company do at this point to improve its current situations? And this is not an uncommon situation, right? Having a code base with a poor architecture is a frequent occurrence, and I see engineers often kind of blame the organization for not thinking about these problems earlier, and then they are stuck feeling like they can't improve the situation. Evolutionary architecture is a way to incrementally improve the architecture of a code base without having to do a big rewrite. It's a way to make the code base better today than it was yesterday, and make it even better tomorrow. And like I mentioned, this situation is not unique, right? I feel like it's the norm. Most companies will start, or products will start with a simple architecture that's good enough for the first few features, and as the product grows, the architecture becomes the bottleneck. So instead of worrying about the decisions you could have made in the past. Basically consider where the product, the architecture needs to go a year or two from now, and try moving toward that. So let me give you one example. Is if we have a new prominent feature that we want to add to the product, we could consider this good architecture and kind of apply the lessons to adding a new feature. So here's an example. Is we still have the current architecture here, but when we add a prominent new feature, we decouple it from the rest of the modules, using the approaches from the previous slide, from that of a good architecture. So we've listed all the benefits earlier for a good architecture, so we do get a lot of those, but we do have some other benefits to consider, right? We're breaking this up by feature, not necessarily by a product team. So in this case, the feature itself would be easier to test and easier and faster to test. The organization itself gets a potential benefit, an option in the future to quickly create a new team dedicated to this feature, right? So we're thinking ahead. Possibly this feature would be its own team in the future. So the code is already split up and independent to get ready for that. From the engineering side, engineering can scale this specific feature separately from the rest of the product, right? This database could be scaled completely differently than the rest of the product, or this feature could be split up into its own microservice. Okay, well, it's nice hearing about these theoretical examples and looking at these pictures, but seeing an actual code example is even better. So I started creating a code example. It's not a complete process, and perhaps if you don't want to get into the details, you can stop the video right now, but let's dive in. So in my code example, I start at the bottom. Here we go. Here's my pen. I start at the bottom, and it's not a complete example, but it's a starting point and kind of a reference of how you would go about doing this. So let's go ahead and jump into the code example and dive into some details. Okay. And this is a files change. They're not in any specific order. So I'll just talk through them in the order they appear. And note, this is just a start, so it may not be complete. All right, in this makefile, test schema. So for testing purposes, we want to have the new schema separately. So main schema is already here, and the feature schema is separate. So basically have to update the file to generate two schemas now. This prepare file is for doing the migrations. So schemas are different, so migrations are different. Here it's largely a copy and paste, right? We had some previous code that did migrations, and then we basically just, this in the future we'd want to refactor this a little bit better, but here it's a copy of the previous code. We check the migration status and then report some errors. Okay, we check the migration status. Okay, all right, and down here we actually do the migration, right? If the migration needs to be done, we actually do the migration for the new feature. All right, here we have serve code. So this is like previous code was just to do a migration. It's a separate executable. Here we have the actual server starting up. And yeah, it just checks for the migration status, kind of similar code that you saw earlier. This is just a note. There's another executable that needs to run. And this is just a note to basically add the check for the migrations here as well, which would be similar to all this code. Just a note to add some more testing, because we do test the migrations. So we want to make sure we're testing the migrations, the kind of legacy migrations, as well as migrations for the new feature. Okay, here we're using MySQL as a database. So here's some methods to do the migrations. This basically calls into this code, so we'll look at that code later. Let's see, load feature migrations. We check a table. The migration status is checked and is held in a table. But I guess the thing I mentioned about here is largely this is just similar to legacy migrations. All we did was change the package here. Let's move on. Check feature migration status. I think this is kind of the same. A lot of this at this point is a copy and paste, right? Oftentimes when you're starting to restructure the code, you're just gonna do a copy and paste. So this is in process, and hasn't been, I think I kind of left it as a copy and paste because it's easier to read that way as opposed to trying to refactor it at this point in time. Compare my table migrations, also kind of a copy here. Testing utils. Okay, so I do want to make a note here, and I feel like I could have kept this out of this branch, but in this case, what I'm doing, what this code is doing, is it's reading in the schema, the original schema, and I'm also reading in the feature schema as well, and I'm just kind of smashing the two together and putting them into the same database. I feel like that's a choice, whether you want to have a test that smashes everything into the same database. I'm now thinking of narrow testing. I really don't want to be testing my feature and have all this other code from all these other tables from the original schema still in there. So my current thinking is like, this shouldn't be the general case where you're bunching all the schemas together. Maybe you have a test that tests the entire code base that does that. But I think generally I would want to keep the tests for these separate. This is just a sample migration. We have a create feature table. Test for the sample migration doesn't really have anything in here. And this is, you see the directory path here? So down here on the left, so we have a new directory called, let me see, what do we have here? I think the directory is called, yes, the directory is called feature. And then in subdirectory, we have MySQL migration. So a lot of these files here, log migration test, these are largely copies from the main files. Like I mentioned before, the initial restructuring or refactoring often involves making copies of files, and then this next pass would be to actually try to refactor them and put the common logic into a single place. Okay, let's see. Yeah, so some helper methods, open a database connection. Yeah, there's nothing new here. It's largely just a copy. And this is the new schema for our feature. This is just an example. So we just have that feature sample we showed earlier, and then we have a table migration status that keeps track of where we are, whether we need to do another migration or not. Yeah, this is just an interface method. Mocks were updated. This is a note to add a debug a debug hook for the migration, for the feature migration, because we have a general one right now, so we need to kind of extend this API to get status of separate migrations. Schema generator for this feature, largely a copy of the main schema generator. I think the only difference is it checks the feature migration status as opposed to the previous table. It was called something else for the main migration. So all in all, just to get that split, it's not that much code, right? It took me maybe about an hour to figure this out. And the next step would be kind of continuing up the stack here and kind of splitting up the data store layer into their own module and then splitting up the service layer, or I could do them in either order and then move up to the front end. Okay, that's it for today.